All right, let's take a look at a little bit more conditional probability. So let's say we got a math class that's got only freshmen and sophomores in it, very much like our own Math 1010. Majority of folks are freshmen and sophomores. On a recent homework assignment, everybody got an A, B, or C. So we have the distribution shown here. So for example, let's say these three students, right? Basically, these are sophomores who also got B's on their assignment. So that's what these entries mean, right? They should have a row and a column meaning to them. So let's start with the first part. If a student is randomly selected from the class, what is the probability that the student got a C? Well, the first thing we could do is we could say, well, how many C's were there, right? There were 7 freshmen and 7 sophomores each who got C's, so there were 14 total, right? So how many did the thing that we were looking for, which is getting a C? We had 14 of those. And then we got to figure out how many total are in this class. So there's a couple different ways we could do this, right? We just add up all 6 numbers. The other thing you could do is look at like either the row totals or the column totals, doesn't really matter which one. So let's say I look at how many freshmen there are. I would add these guys up and I would see, oh, there's 24 total freshmen. And then I would add these up and I'd see there's 18 total sophomores. So I could add those two together and I would get 42 total folks in the class. So 14 out of the 42 ended up getting a C on this assignment. Yes, a lot of times we're going to have fractions. You can simplify a little bit. And so this would actually simplify to 1/3. But for the most part, I'm okay with not simplifying these, just kind of leaving them as is, especially because sometimes we want to compare to other scenarios. All right, let's look at part B. So this one, right, and I should mention, part A did not have a given portion, right? It was not a conditional probability. It was just a basic question, kind of reading the table. Part B, if a student is randomly selected from class, what's the probability that the student is a freshman given that they got an A? So this is, right, if we're using probability notation, I could have included that. C on the homework. I could have included that in the first part, right, and use proper probability notation here. We're saying, what is the probability that they're a freshman? I'm just going to do FR, given that they got an A. Right, so this is kind of a nice shorthand for that. So remember that this is the probability that both things happen. So freshman and they got an A divided by the probability of getting an A. So we could use the formula for this, but it turns out we don't really so much need that. We can just kind of use a little bit of logic when we have a table here. So if I want to say given that they got an A, basically what we're saying is I'm only interested in the people in this first row, right? So given that we land here, we want to know what is the probability that the student is a freshman. Well, okay, how many people in total got an A? 12 in total. Of those 12, right, 4 plus 8 is where we got the 12. So of those 12, how many of them were freshmen? Well, that would be 4 of them. So of the people who got A's, of those 12, 4 of them are freshmen, so our probability is just 4 out of 12. Again, this thing actually simplifies to 1/3 just by coincidence, right? These are totally different questions, but kind of same answer. And so we didn't really use the formula version of this. We could have done, and that would have been totally fine. You get the same answer once you kind of clean up some of the mess in there. But I think that this is a little bit cleaner, honestly. So yeah, if we can use the table, just go directly for it. We didn't need the formula there. All right, let's look at the next example. So we got 3 cards are dealt without replacement from a standard deck that's been shuffled. So one thing to note is that, yeah, a lot of times in this course, we're going to use dice, we're going to use coins, we're going to use decks of cards. So if you're not very familiar with decks of cards, it's always good to remind yourself where, what's going on in the deck of cards. So we have 52 total cards. And one thing that we're going to be interested in are the suits of those cards, because we're looking at hearts, and not a heart. So basically looking at the different suits. So there are 4 suits, and those are evenly dispersed. So that means there are 13 of each suit. So, right, all the individual cards, we know some of those probably, like the ace of spades, the 10 of hearts, those are pretty commonly heard cards. But, right, the 4 suits are going to be hearts, diamonds, those are the 2 red ones, hearts and diamonds, and then clubs and spades are the black suits. And then the 13, well, this is 2 through 10, regular numbers, and then we have jack, queen, king, and ace, right? We don't really need all of that information for this, but we just need, right, if there's an even dispersal of suits, then we say, well, if I start off with the entire deck, so all 52 cards, what's the probability the first card is going to be a heart? Well, there are, as we mentioned, 32 of each suit to start. So there are, right, if I want the probability of just getting a heart, then I have 13 hearts in the deck and 52 total cards. Another way to say this is 1 out of 4. Right? Again, the 4 suits are evenly distributed, so 1/4 kind of makes sense for that first part. So this is not a conditional probability, right? There's no given portion. But when we get to part B, we do have a conditional probability. So one thing we can do, write it out with probability notation. So find the probability the second card is a heart, given that the first card is also a heart, right? So this one is find the probability that we get a heart, given the first card was a heart, right? Yeah, that's not terribly clear. Let me make that a little bit more clear. So first card, whoops, sorry, second card rather. All right, we want to know what's the probability the second card is a heart, given the first card is a heart. All right, well, I could use the formula for this one, but honestly, I think we can use a little bit more logic, so we don't have a table to go off of, but we can think to ourselves, all right, I'm not replacing these cards. So I dealt the first one, it happened to be a heart. So then we just say, well, how many cards are left, right? Well, I had 52, so I dealt one of them, I should only have 51 left. And if the first card was a heart, right, given that the first card was a heart, that means I had 13 of them. Well, there's only going to be 12 left because the first one was one of those hearts. So I've got 12 other ones left in there. So this is the probability of getting the second card as a heart given the first. All right, find the probability that the third card is not a heart. So probability third is not a heart given the first and second are hearts. All right, so that's a little shorthand, but I think it's fine enough. Well, okay, again, let's just kind of use logic with this. So by the time I get to this third card, I've already dealt out 2, right? So I started with 52 cards in the deck. 2 of them have already been dealt, so I guess I've only got 50 left. And here's where we kind of break from the pattern of the first 2, right? So we said, well, I had 13 hearts. I dealt 1 out, so I was left with 12. I dealt 1 out. So we have 11 hearts left. Well, that's a really bad heart. Yep, sure, good enough, whatever. So we have 11 hearts left, and then we have all the other cards remaining. So there were 13 diamonds, 13 clubs, 13 spades. So that means we have 13 times 3, so 39 others left. Right, basically all the others. So what's the probability we get a card that is not a heart? I don't really care what it is, just that it is not a heart. So there are 13 cards that fit that description, or sorry, not 13, 39 cards that fit that description out of the 50 that remain. So that's going to be our probability. So we're accounting for the things that have happened previously, both in the denominator, the bottom of the fraction, by saying, okay, I've dealt out 2 cards, so this number's got to go down, but also in the top of the fraction, we're saying, well, based on what has happened up to this point, does it affect what I'm looking for? So that's kind of the idea on some of these. We don't need the formula, but we absolutely certainly could have applied the formula to these if we so chose.